Okay, so if we're gonna finish identities, just the basic identities and using those. Yesterday, we talked about the second part of the warm-up. Okay, but I didn't address if there are boundaries, if they give you angle boundaries with those problems. So I'm going to show you that first. So I'm just going to pick one from the book here, see how it ends up. Cosecant is negative, no, it's just root 11 over 3. Our boundary, pi over 2 to pi, and we need to find cotangent. Okay. We did the simple version of these yesterday. What? Better? Good. Yeah. Okay, there are a couple ways to do this. One is the knowledge you already have. Okay. The second one is with the identities. Okay. What identity relates cosecant and cotangent? You can look it up. One of them. Okay, so we can use this to calculate cotangent. There's just a little twist at the end that you need to be aware of. That's what the boundary does for us. Makes it just a touch more difficult. Not much though. So I can plug root 11 over 3 in for cosecant. Okay. You all right? Good? Okay. All right. Now I'm going to subtract 1, which is 9 over 9, correct? So what do I get on that right side? Yeah, 2 over 9. And then square root both sides. So I end up with cotangent theta equals positive or negative root 2. Let's just make that root 2 over 3. Okay. We're not done yet, so don't relax. This is where the boundary comes in. These ratios cannot be two different numbers. So we can't have a positive and a negative root 2 over 3. So we have to consider what that does for us. So, we go back to the unit circle. Where is pi over 2 to pi? What quadrant? No. Anybody else want to guess? It's quadrant 2. So pi over 2 is 90 degrees. And pi is 180 degrees. So we're in this quadrant. Okay. If I draw a right triangle, cosecant is root 11 over 3, right? And that's hypotenuse over adjacent. Or sorry, hypotenuse over opposite, right? Because it's the opposite of sine. Right. Cosecant is the reciprocal of sine. Sine's opposite over hypotenuse. So we have root 11 and 3. Well, we're in the unit circle. Oh, it just drew it so that it was on the circle. It has to be in quadrant 2. Are you with me? Or against me and I get to chop your heads off? That part? Thank you, Mikey, for permission. Do you understand what we're doing? Where I've gone here? Some of you.
Why is there like a floating sign?
What, this? It's quadrant 2.
Oh, that's the tree.
Oh, that there. That's better. Because see how that's root 2? We know that's root 2. Root 2 over 3 is cotangent. Is that a negative value in the x or positive? Right. So we know that we need to pick the negative root 2 over 3 because this is a negative x value. Okay. That just determines positive or negative.
So you really have to do
You don't have to draw it if you can look it and see it. We can do this without identities. You want me to show you that?
Is it easier?
Some people think it is. I think it is. So I got to start here with the unit circle, right? So if I draw a triangle, let me use colors this time, maybe it'll help. In quadrant 2, I know that, what were we looking at here? Cosecant is hypotenuse over opposite, right? So that means that this is root 11 and this is 3. We're looking for cotangent, which is adjacent over opposite. So we need to find the value there for A, right? Using what theorem? Yeah, you can use the Pythagorean theorem now. So root 11 squared is 11. Subtract the 9, you get 2. Is A squared. Take the root there, of course, and you get positive or negative root 2 is A. Okay, which one is it? It's an x value. To the left is negative. Okay, so x values are negative here, positive here. Y values are negative here, positive here, right? So we need negative root 2, and we know we have that. So is that easier?
Yeah.
Okay, so use that. That's fine. And that's the method you could have used from your prior knowledge. So one or the other, it doesn't matter to me. Take your pick. I am showing you all the identities because we need to get used to seeing them and using them. Good, good, good. What's next? Something that I didn't show you yesterday, but they're very useful at times, are the opposite angle identities. Sometimes it's pretty handy to get rid of the negative angle. This allows us to do that. Okay, so these are telling us that like sine negative 45 is equal to the negative of sine 45. Those are equivalent expressions. The cosine one's really neat because the cosine of negative 45 is the same as cosine 45. They give you the same value. Okay. So use them as you need them. Right. Well, let's build it up. Tangent is sine over cosine, right, from yesterday?
Yeah.
And now we use the other two to finish it off. So you only really need to remember the first two, and you can build tangent. So we have negative sine over cosine. You can use the same thing I just did for tan with those. Yeah. Yep. Okay, so the last part of this section is simplifying these expressions algebraically using your identities. We're headed towards actually solving trig equations, and this is just kind of the first step, you practicing your algebra simplification. When you want to simplify these, we're just going to start plugging identities in and seeing if it gets us anywhere. So cosecant is 1 over sine. And what's cotangent? It's 1 over tan, but is there a tangent in there anywhere? Okay, so it probably wouldn't help. What else is cotangent? What'd you say, Matt? Cosine over sine? Is he right? Okay, so now we're all in terms of cosine and sine. Okay, this is kind of where you want to head with a lot of these. You're just getting rid of it and making it more simple. 1 over sine x minus cosine times cosine over sine. So here's where we are. Right? Because they have a common denominator, 1 minus cosine squared x. I need to use this identity to get rid of the top. Okay. If I subtract cosine over, I can see that now these match, right? So I'm going to substitute sine squared x for the top. That's kind of that's what a lot of people get confused about, using this identity. So all I've done is taken the Pythagorean identity and subtracted cosine over, and now my top matches that, and I can substitute. Okay. So our answer in the end, yep, is sine x. That is where?
How do you got the sine x squared over sine x?
Okay. This, you know where I got this part?
Yeah.
You good there? Okay. This identity, you're familiar with from yesterday, right? So if I subtract cosine squared from both sides, I get sine squared x equals 1 minus cosine squared, right? That matches the top.
Oh. So then you just like.
Now you're going to put sine squared x in for it. You're substituting, because they're equivalent expressions, you can take that and put sine squared in for it. And now we can simplify. Just did it for her. Anybody else?
Yeah.
It's called substitution. You guys, let me see if I can find a. What if I did? Let me put this up here. And this is an algebraic example. Maybe it'll. That system of equations, they're both equal to y, correct? So can I say this? Yeah, that's the same thing. Algebraically, it's the same concept. You're just using the trig functions in it now. Okay. So it's substitution, that's what it's called. Okay. Do you want me to show you another one of those? Okay. I'll show you the one I showed last hour. It's easier. Let me go. Let me make sure I get it written down. You awake? It's so fun. This one's a touch easier than the last one. What can I do to that algebraically to simplify it? No, we can't add the sine x's because one of them has a cotangent attached. There's no equal sign. Can I take sine out of both of them?
Yeah.
Okay, so let's do that. What's left over? So I've factored algebra, right? There's an identity. What does 1 plus cotangent squared equal? It's one of the Pythagorean identities. So I can substitute now. And get sine x times cosecant squared x. Good? Okay. Cosecant, what is that? Yep. In our case, it's 1 over sine squared because it's cosecant squared, right? And now what's my answer? Well, 1 over sine x, which is cosecant x. Okay. That was a little easier. But again, you're using your identities to simplify. Okay. So all the identities we listed yesterday and the 2 today, use those to your advantage, okay? I went ahead and took 12 and 13 out of the assignment. You're welcome. So you can cross those out, but the rest of it remains. Okay. You have upwards of 22 minutes, so you could probably get most of this done if you put your minds to it. Try to get to, definitely try to get to 14, 15, and 16 so you can see, try some of those last couple of problems that I showed you on your own. If you need help, I can help you.